Find the coordinates of the circumcenter of the triangle with the given vertices. So in order to do a problem like this, you've got to know what this means, circumcenter. Okay, so the circumcenter is the point where all three perpendicular bisectors meet in a triangle. Okay, sometimes it's inside the triangle, sometimes it's outside the triangle, sometimes it's right there on the hypotenuse of a triangle if it's a right triangle. All right, so in order to find the circumcenter, we have to find where two perpendicular bisectors intersect. Now you could find all three of the perpendicular bisectors, but you only actually need to find where two of them intersect to find the circumcenter of the triangle. All right, so let's go ahead and you can use any of the three sides. So you pick two of your favorites. I think these two right here, AB and AC, would be the easiest, but I want to show you how to do a side like BC as well. Okay, so I'm going to do one of the easy sides and then side BC as well. All right, so let's find the perpendicular bisector of side BC first. So perpendicular bisector, think about what that means. So it's a line that goes through BC that is perpendicular to it, so it means it hits at a 90-degree angle, and it also bisects the segment. So right here in the middle is where it's going to go through. So we can kind of like estimate some line like this, right? Something like that, where it's hitting at a 90-degree angle. Okay, so if I find that thing, the equation of that line, and then I find the equation of another perpendicular bisector, like over here, that one, their intersection point is going to be our circumcenter. Okay, so in the problem, they didn't give you this drawing, but I think it's always easiest in coordinate geometry if they give you the vertices, like ordered pairs. I would draw them out, at least kind of sketch it so you can see what you're working with. So let's go ahead and first find the, let's put perpendicular bisector of BC. We'll do that line first. Okay, so in order to find the equation of that perpendicular bisector, I need to first find the slope of line BC, because we know about perpendicular lines and their slopes. We know they have opposite reciprocal slopes. So let's first find the slope from B to C. So let's say slope of BC, which we know is y2 minus y1 over x2 minus x1. So let's go ahead and fill in our y2 minus our y1, so 0 minus 6, over our x2 minus x1, so 10 minus 0. And that would be a slope of negative 6 over 10, which reduces to negative 3 over 5. Okay, so the slope that we just found right there is the slope of BC. So we're looking for the slope of the line that's perpendicular to that. So take the opposite reciprocal of this guy. Opposite reciprocal, meaning if it's negative, make it positive and flip the fraction. So the slope of the line we are looking for is 5/3. All right, so we got the slope. We're trying to write the whole equation of the line though, so we also need a point that this line goes through. Easiest point to find would be this one right here, which is the midpoint of BC. Okay, so next let's find the midpoint of BC. Okay, and in order to do that, midpoint's really easy. You just add the x's together, divide by 2, add the y's together, divide by 2, and you got the middle point. Okay, it's just like averaging numbers. So if we add the x's, that'd be 10 plus 0, which is just 10 divided by 2, there we go. And then the y's would be just 0 plus 6, which is 6, divided by 2. So our midpoint is the point 5, 3. All right, so we found our slope. We have a point that line goes through. So I can now write the equation of this perpendicular bisector using point-slope form. Okay, so point-slope form is y minus y1 equals m times x minus x1. Some algebra stuff going on here. Okay, for point-slope form, we don't substitute anything in for y and for x, but we do for y1, for x1 and for m. Okay, so if we say y minus our y1 is this y value that we found. So y minus 3 equals, and my m is now the 5/3 that we found, that slope, times my x minus my x1, and my x1 is just this x value that we found. And you're going to have some fractions to deal with, but we can whip out a calculator and use that. Okay, so let's simplify this, distribute 5/3 to everything here. That becomes 5/3 x, and 5/3 times -5 would be -25/3. Again, you can use a calculator if you'd like. Okay, we want this in y equals mx plus b form, so we need to add this 3 to both sides here, and we get y equals 5/3 x. And if you want to put in this calculator, I can do that right now for you, so we don't have to deal with fractions here. -25/3 plus 3. And that gives us -16/3. So -16/3. All right, so that was kind of challenging, but we found the equation of one of our perpendicular bisectors. That is the equation of this line we drew here. So we need one other equation, and we picked this one, of another perpendicular bisector, and then we can find their intersection point, which will be our circumcenter. So let's go up here a little bit. Okay, let's find the perpendicular bisector of side AB. Okay, so let's perpendicular bisector of AB. Okay, and remember, to find the perpendicular bisector, we need the slope of the line, and we need a point through the line. Okay, so if we look at this, this one's going to be pretty easy. The slope of this line that we're looking at right here, it goes straight up and down. It's a vertical line. If you recall from algebra, a vertical line has a slope that we call undefined. All right, and we want the one that's perpendicular to that, so it's going to be a horizontal line. Okay, and if you also recall from algebra, the slope of a horizontal line is 0. So I don't have to calculate anything. I just know my m, or my slope, is 0. All right, and then we also need a point, because to write the equation of this line, we need a slope and a point. So find the midpoint. That's going to be the easiest point. Midpoint of AB, well, that one's pretty easy to find. We could do the equation, or we can just count from here to here is 6. The midpoint's going to be halfway, so at 3. And that would be the point 0, 3. So our midpoint is 0, 3. All right, so to write the equation of that line, if you want to go ahead and use point slope form, of course there's a shortcut here I could show you, but let's go ahead and fill it into point slope form. Y minus y1, well here's my y1, equals m, which is 0, my slope, times x minus x1. So x minus my x1, which is 0. All right, if you notice, this is 0 times something. Well, 0 times anything is just 0. So that becomes y minus 3 equals 0. Add 3 to both sides, so you get y equals 3. And what we just found here is an equation, or the equation for the other perpendicular bisector. So now we've got this equation, we've got this equation, which makes us have what we call a system of equations. And if we can find the point where those two equations intersect, then we have found our circumcenter. So let's go ahead and do that. All right, so system of equations. I think the best way to do this is going to be by substitution. So if you notice, we have a variable already solved for. We have y equals 3. So you can take the value of y, which is 3, and plug it in for y into the other equation. So if I write that, I get 3 equals 5/3 x minus 16/3. And we're solving for x right here. We can add 16/3 to 3. Let me get my calculator. 3 plus 16/3. That gives us 25/3. equals 5/3 x. And to get x all by itself, you could multiply by the reciprocal, which would be 3/5. If you want to put that in your calculator, I believe that is just 5. Let's see, 25/3 times 3/5. And that does give us x equals 5. All right, so we're trying to find the intersection point. We found the x-coordinate of it, and we also already have the y-coordinate of it. So we have our answer, the point that all these perpendiculars bisect is 5,3. Whew. And that is our circumcenter. Let's double check that up here. Does that look like 5,3 in our picture? 1, 2, 3, 4, 5, up 1, 2, 3, bam, there it is. We did it. Good job.